So we have spent some time looking at triangles. We've started into our triangle unit here, and we spent some time together talking about the different types of triangles. We've classified them by their angles, and then there's another set of classifications by their sides. And we should have this front page filled out by now at this point. And then if you flip the paper over onto the back, during our last session we talked a little bit about interior angles of a triangle, and that every triangle will have angles that add up to 180 degrees. So we looked at some examples where they gave you two of the angles, and you have to find the third by just essentially subtracting the two that they gave you from 180, because there's only going to be one number that ever fits into that spot to be angle B. So today we're going to pick up with that conversation. If you look at the bottom half of that paper, you see this example up at the top, and it walks you through it, but we're going to do a couple together as well. But really it jumps on this principle that because we know all angles have to be 180 degrees, we can include a little bit of algebra into this combination. And so we know that one angle is 30 degrees, and so that's where we started. And then we add the 25 degrees to that. And then our third angle here is that 4x plus 25. And those are all three of the angles. And again, we know that they have to equal 180 degrees. So there's a couple familiar terms I'm hoping that you see here, that the first thing we need to do is combine some like terms. There's a lot of just single numbers here that you see combined down here to get 80. And then that 4x gets brought down. And now at this point we have one of those two-step equations that we can isolate our variable and do things to either side to get our x alone. So in this case, you see that work out to get you to x equals 25. So really all of this just stems from the fact that we know that when we put all three of these angles together, we need to get 180 degrees. So I'm going to follow that similar process with those examples down at the bottom of this page. We're going to work through these together, and we should be filling in our notes as I am up here in the video, and then you'll try some examples on your own. So we see in this first example we have 77, and then we're adding to that 50, and then our third angle is where we see that x, 7x minus 3. But we know, because it's a triangle, that all together needs to equal 180 degrees every single time. So my first task is going to be to combine these numbers that I see. So I have 77 plus 50, and then plus a negative 3, or minus 3. And so when I put all of that together in my calculator, I got 124. And then of course my 7x term just stays put by itself. So I'm going to add 7x to that, and I'm going to get that again, that needs to equal 180 degrees. And now at this point we are going to just solve our two-step equation by circling the variable and the number with it. Drawing my line down just for our organization piece, because I have 124 here, I know I need to subtract 124 from each side. So 180 minus 124 gets me 56 over here, needs to equal 7x. And so in order to get that x alone, I know I need to divide by 7 on both sides, which gets me that x equals 8. So that's very helpful in solving this piece. We now know that x equals 8, but now the real question is, well, what does that angle equal? And can we plug that in and just make sure that that's actually true? We know that 7 times 8, or 7 times x, is 56. And then if we subtract 3 from that, we get that this angle equals 53 degrees. And just to double check, we of course know that all three angles together need to equal 180. So if I take 53 and add it to 50, I'll get 103. And then if I add that 77, I'm going to get my total sum is 180. So just a way to always be double checking your work. So we'll do the same thing over here with example number 2. My first step will be to just write all of them out, because we know all of them together need to equal 180. So 31 plus that 39 in the upper corner, plus 11x plus 11. I like to just string them all together so I know that I haven't missed one of the angles. And then of course we're going to just combine all of those numbers, make it look a little nicer. So 31 plus 39 plus 11 gets me 81. And then, of course, my 11x just gets to come right down, and all of that needs to continue to equal 180 degrees. So as I start to solve my equation, I'm going to circle that piece with my x and get rid of my 81 first by subtracting. That's going to leave me with 11x on this side, because my 81s will go away. And 180 minus 81 gets me 99. And nicely, we would divide both sides by 11, and we get that x equals 9. 99 divided by 11 gets me 9. So the question is, when I plug that back in, what does that angle measure equal? Well, we have 11 times our x, which we got to be 9, plus 11. So that would be 99 plus 11, which gives me 110 degrees, which makes sense. I mean, even just with this picture, we never like to trust pictures, but this is a obtuse angle. We know that 110 is obtuse, which makes this an obtuse triangle. And of course, just to double check, we know that 39 plus 31 gets me 70, plus that 110 gets me that magical 180 degrees for this triangle. So that's essentially just that combination of what we know about triangles and some algebra included. I have another assignment here for you just to practice just stringing all of these together. Should be a paper that looks something like this, and I do have some of those first couple examples worked out for you where you're solving for x and then of course telling me what that angle equals by itself. So give that assignment a try and move on into the other activities listed below.